Hello and welcome to Season 4 of the SoundStage Audiophile Podcast. For the past few years, host Jorden Guth has been learning about the who, the what, and the when of hi-fi from the pioneers who made our hobby what it is today, as well as the modern innovators who are constantly striving to push performance to new levels. That's not going to change, but this year he'll also be learning about the other two W's, where your favorite gear is made these days, and why. So with that out of the way, let's see who Jorden is chatting with this time around.
Hello and welcome to the SoundStage Audiophile Podcast. Today we are at KEF in Maidstone, Kent, England, with Jack Oclee-Brown, VP of Technology, where we just finished day 2 of filming, and we're actually recording this in April, but this podcast isn't going to be released for at least a couple months, and a lot of that is to do with what we're talking about today. So thank you for coming back on and sitting down with us again.
No problem, Jorden. Very nice to talk to you again.
Yeah, it's been so long. So we're talking about some of the technology that we've seen over the last 2 days, and it's really cool. It's quite technical, so we'll kind of get into the technical bits, but we'll take it from kind of an introductory level and then get more technical as we go. And then we could talk a little bit about the product that's going to get launched in, because I think that's also kind of a neat technology and product.
That sounds good. Sounds like a plan.
Awesome. So the technology, and you already have a cool name for it as well.
Yes.
So what are we calling this?
It's VECO, which is kind of shorthand for velocity control.
Velocity control.
Yeah. I mean, maybe as the best kind of background into this is to give it a bit of context. So we've been making speakers for a long time, right? But over most of our history, we've made passive loudspeakers, right? So the customer has to have an amplifier, and we don't have a lot of control over what the customer's going to use, right? And that's how the industry has been 50, 60, 70 years, right? That's how it is. But the way we've all settled down into like happily cooperating with some companies making speakers, some companies making amplifiers is, we have a set way of doing things. So the amplifier that you can go and buy from a hi-fi shop, will be rated for 4 ohm speakers or 8 ohm speakers. And that's what the loudspeaker manufacturers make, 4 ohm speakers, 8 ohm speakers.
Yeah.
And then, the other kind of commonality is amplifiers provide an output voltage, which matches the kind of music signal that somebody wants to listen to. And that's the way we do things. And it kind of works on both sides. Amplifier designers, they know what they're doing. Loudspeaker designers, we know what we're doing. And everyone's happy. And we don't have too many occasions where somebody says, wow, your speakers really don't work with this amp I've got. So yeah, that's where we are really. And I think the interesting thing that's happened in the last, for us, coming on for 8 years, is that we're starting to make a lot of products where the amplifiers are in the loudspeaker.
Yep.
And that hasn't been the case in our history for, the majority of it, except for subwoofers.
Sure.
We've been doing subwoofers a bit longer, but I'm talking about, full band loudspeakers. And so some of these norms that we've become used to, we've been going back and saying, well, is that the best way to do it? Is there a way we could get some kind of performance advantage by doing things differently? And, on our radar, we've had lots of different things. For example, if you take a look at some of our recent products like KC62 or LS60, we've been really thinking hard about what should the driver, design be like. And, on those products, you've got a lot more radiating area than you get away with in the same size passive speaker. And that means we can give more bass and a louder output in small cabinets. And that's what some of our customers really love. So that's all great. So it's been across the board, looking back at some of the things we do and saying, well, is this really the right way to do it? And with our kind of push as well to try and get more and more bass out of small enclosures, distortion has kind of been on our radar because you don't get anything for free, right? So with something like KC62, you got very little volume, and we've got kind of a lot of driver area in that. And so to make it work, we have huge amplifiers, like 500 watts on each of those drivers. So 1,000 watts in a small package. And, the DSP is working away really hard, trying to kind of overcome the physics of that situation. And we have systems we've developed in that to try and make sure you're not getting loads of distortion when that little cube's trying to give you 20 hertz, for example. So yeah, we've been kind of on this path, and I think this has been the culmination of a lot of, questions over the last 6-7 years of, where are we going? What's our best way to do things? And VECO is the result. And it's a bit of a kind of like step away from what we've been doing in a way. So I mentioned KC62, LS60, we kind of use the DSP to try and get rid of some of the distortion. And that's a trick which there's a few people in the industry doing. So you have to have like a good understanding in the DSP of what the speaker's going to do, what the driver's going to do, kind of try and predict its behavior on the signal you're getting in to replay. And then you try and guess. Oh, well, guess is maybe a loose term. Predict the distortion and cancel it, right? And we've been finding that approach is great and we can get a certain amount of control, but we were kind of like seeing the limitations and thinking, in the future, we want something better. And that got us thinking about actually having some kind of sensor in the driver where we can instantaneously see how much is the cone moving, which in itself is like, that's not groundbreaking in the sense that like Philips were doing stuff a bit like this back in the 80s. But for us, it was kind of a quest to develop a sensor which we could put into things, see the cone motion. It's something that's very versatile, lightweight, can be built into most of our products. And VECO is basically what we've come up with. And long time in development, I can tell you that, and quite a hard slog. So it's kind of refreshing to be able to talk to you about it.
And we were kind of talking about this over the last 2 days quite extensively, and maybe I'll take it back just a little bit. So the premise behind it is you're looking for a way to reduce distortion, predominantly in the bass, in the low frequencies. Yeah. And you're racking your head on DSP, but that will only go so far. That's basically a feed-forward system where you're doing predictions. Yep. Good guesses. Yep. Maybe better than that. So the feedback system would actually allow you rather to see what's actually happening and then influence the driver motion based on what's actually happening to kind of reduce some of the nasty stuff that comes along with these packages.
Yeah, 100%. So and negative feedback is maybe familiar from amplifiers and other devices that use it. So you kind of have a sensor which detects what the output's actually doing, and then you create an error signal between what the sensor's doing and what you want it to do. And that's how it works.
Gotcha. And then your approach to this, or this idea, and we kind of talked about this a little bit, which was really cool, which is where you thought about this idea. But I'll kind of frame it in the sense that there's two main components, and correct me here at any time if I'm getting this wrong. But one of the main components is the difference between voltage drive and current drive.
Yep, that's true.
And then the other component is actually the sensing component to understand what is happening.
That's absolutely right.
So give me a little bit about this inspiration, this light bulb moment, and where this kind of thought was like, oh, this is an approach that we can start looking at.
Yeah, I guess maybe one thing to say is, you're right to say, well, there's these two components. Yeah. But and we're using them together. Yes. So the current drive and the motion sensor, or the velocity sensor in our case. But the velocity sensor, you could use it independently. But the recipe of the two together is really beautiful, really works well. But we can talk about the velocity sensor first.
Okay, sure, yeah.
Because it's kind of easier to get into the idea of that. So we want a sensor. We want to build a sensor into our drivers. So how do we do that? So, accelerometers, they're a great way to sense motion of something, right? And accelerometers are everywhere. You have accelerometers in your phone, which was the Nintendo console, the Nintendo. Switch. Well, even before that, the Wii.
The Wii. That's right. Yeah, so, with the little Joy-Cons.
Yeah, and you can get these little accelerometer ICs now. And Philips put an accelerometer in some of their drivers back in the 80s, and then there's other companies like Velodyne, and that was something we thought about. But one thing that we really wanted was a really simple sensor that didn't need like much space in the driver. We also wanted something where we don't really have any problems of where we've mounted it in the driver. So, if you've got to mount it on a little extra piece that you put on the voice coil or something, then you have to worry about resonances in that. And then you also have the problem that you need to get some power to the driver so that you can power up your sensor.
Yeah.
So we were looking at it. We were looking at other things as well. But ultimately, I guess we came back to what we know really well, which is electromagnetic motors, right? That's what a loudspeaker is. And we're well, I shouldn't maybe say this, but we're quite good.
You don't have to be that modest. KEF is known in the industry to be quite up there.
Yeah. Well, we're kind of familiar with electromagnetics.
Yeah.
And one way you can make a sensor is basically by using a loudspeaker motor, right? So if you don't drive it with a signal, but you just move the cone with your fingers, say, then you will get a voltage on the terminals of the driver that's proportional to the velocity. So yeah, and that effect is based on a physical principle called electromagnetic induction. It's something we deal with every day. And so it's something we're really familiar with. And in the history of this idea, other people have thought along the same lines. So you could take a driver, for example, and put another winding over the top of the voice coil. And the good news is it doesn't need to carry any power, really. So it can be really fine wire.
Yeah.
And then, the idea is from that other winding, when it's moving along with the voice coil and moving in the magnetic gap, you would get a signal proportional to the velocity. So, that's a really neat approach. But when you start to look at it in detail, it's got like a big problem, which is when you have two coils which are basically wound over each other, you've made something else. You've made a transformer, right?
Yeah.
So transformers, again, like, I don't want to go back to, maybe physics in high school or something.
Yeah,
but transformers, basically, you can kind of have two coils which magnetically couple, and we can put a signal on the first coil and it'll be magnetically transferred over to the second coil. So the issue there is that you're going to pick up the velocity on your new coil you've added, but you're also going to get some component which is just directly coupled from what you're feeding your voice coil.
I think we're going to have a cool video explaining this and showing a demo of this with the 90-degree.
We do.
Yeah.
We do. So that if what I've said makes no sense,
watch the little video. Yeah. We'll link it in the show notes. I believe that they should be coming out at around the same time when all this is announced. So we'll link that.
So that was then the problem we started to focus on. How do we use basically an electromagnetic sensor, a coil moving in a magnetic field to pick up the cone motion, but avoid this coupling with the voice coil? I know the coupling from the voice coil can be very, very strong because, if we're driving the driver with a couple of 100 watts, we're going to get a lot of magnetic field off that voice coil. So yeah, and then we went down a bit of a rabbit hole, honestly. And it was a long time ago, but suddenly we started to think about a principle. It sounds very technical, but in a way it's very simple. But we quite often use this principle called orthogonality, right? Which is basically saying two things are perpendicular to each other. So, you could have, say, a block that you're pushing along on the table in one direction. Yeah. And if you apply a force, it's going to move along a line in one direction. If you apply a force in another direction, perpendicular, it'll move 90 degrees to that. And those two are independent. If you double the force in the X direction, it moves twice as far in the X direction.
Yeah.
It doesn't affect what's going on in Y. So we started to think about this principle where, okay, maybe we can have two coils that they don't really affect each other somehow. And if anybody's a kind of enthusiastic DIY speaker guy, you might know that with coils that you use on the speaker crossover, you can use this principle there, and it's quite well documented. So if you have two inductors on a crossover and you put them too close together, you've made a little transformer. But if you turn one of them through 90 degrees, so they're perpendicular, then they don't couple anymore. And, mathematically we'd say that's orthogonal. But really the idea is the coils are still there. They're still happily next to each other, but they don't really influence each other. So this was the kind of thing we were thinking about. And it led us to kind of look at a way of changing the geometry of the coil that's going to pick up the motion so that it didn't really get influenced by the voice coil. And we developed then a pattern for the windings that did exactly that. And happily, we're in kind of great technological era that there's all sorts of interesting manufacture processes out there. So we had this like idea, if we had a coil that was this strange shape, it wouldn't see any of this magnetic field from the voice coil. And happily, we found that using printed circuit board technology, we could make that coil. So yeah, we're using what we call the sensing coil, and it's etched or printed onto a flexible PCB, which actually is what the voice coil's wound on top of. So in a loudspeaker, the voice coil's normally wound on something we'd call the former, which is basically a thin cylinder of material. And they're made from various different things, but they're quite often made from like polyimide film, which is the same material as a flexible PCB. So we had this like happy marriage. Oh, hang on, we could use these things all together. So that's what we have, is a coil with a very special winding pattern. So basically it doesn't see the magnetic field from the voice coil.
Yeah. And for those, this is very much like we're talking very, I would say, pretty technically here. For those that like the visual elements, we are going to have videos that kind of explain this more visually and show some of this stuff, because it also just looks really cool. We're talking about a thin piece of, for lack of a better word, like plastic. It's not plastic, but a thin piece of plastic that has 15 meters of wire essentially going on one side of it and another 15 meters on the other side of it that are acting in opposite polarities, to then, when they're combined together and put inside of the former, allow it to not be seen or impact the rest of the voice coil, but to give the readings that allow you through software. And this is all like the electronics of the speaker mechanism itself, to then influence how the distortion is happening. So essentially sensing what's going on, acting on what's going on, and producing a distortion reduced speaker.
Yeah. It sounds complicated. So I think the visuals would really help. But yeah, I mean, the essence of what we've done is that, we have a voltage that comes out this thing that tells us the velocity or the speed of the cone motion.
Yeah.
And that gives us a huge amount of insight into how the loudspeaker's behaving in real time. And that, enables us to do all sorts of things. So, and the goal is, reduce distortion. So that is the goal. And we're still, early days. I guess this technology is probably going to be around a while, and I'm expecting we find other ways to use this signal to, improve what we're doing. But yeah, we're already getting very good levels of distortion reduction with a simple feedback loop based on that. And there's a question then of like, okay, how do we use this? So we could use it in different ways. You could take a hi-fi speaker and we can like reduce distortion, or alternatively we can say, well, let's do it the other way and make a very small loudspeaker with high power amps that, without this tech would have way too much distortion, and use it to make that something which is great to listen to. So yeah, it's kind of exciting.
And there's another piece to this recipe though.
There is. So there's a nice thing that kind of tumbles out of this, if you like, which is with the amplifier, we talked at the beginning, okay, voltage amplifiers are the industry standard. When you go and buy an amplifier from a hi-fi shop, it outputs a voltage which matches your input signal. But I think every loudspeaker designer in the world knows that actually the force that's generated by the motor is proportional to the current going through the voice coil. And the fact that we use a voltage amplifier is for really quite a specific reason, which is a loudspeaker cone, suspended on a suspension. If you use a current amplifier, you get very uncontrolled behavior at low frequencies. The cone just easily excites and resonates at its fundamental resonance. And by using a voltage amplifier instead, we get an effect called the electrodynamic damping, or you sometimes hear it called back EMF, which basically controls that. And that's kind of the essence of loudspeaker design as taught like since the 70s. And, the Thiel small parameters and the analysis by those guys is based on this. But it would be nicer if we're kind of having an amp which produces a current signal which matches the music we want to reproduce. That would get rid of a whole load of horrible stuff that goes on in the motor. And one of the nice things is that once you can sense the motion, and in our case, the velocity of the loudspeaker cone, we can use that instead of this electrodynamic damping effect.
And I want to make sure that I understand this in the sense that the benefits of voltage focused amplification is that back EMF, the damping, kind of makes it more controlled, so there's less resonance and stuff in the sound. But the downside is that introduces distortion.
Yeah. So the amount of distortion you get is highly dependent on the motor. And the industry as a whole has done a huge amount of work on minimizing that. So when you see products that we make and other manufacturers make with, say, things like conductive rings, sometimes called Faraday rings, or copper caps, or using special magnetic materials, a lot of that is there to address the current distortion that you get. And a nicer situation is to have an amplifier which basically delivers the current directly.
Yeah.
And you don't have to have these extra features, not least of all because they're quite expensive, which, is one of the reasons why fidelity costs money. Good loudspeaker, you're paying for these physical parts, these aluminum or copper rings or special materials. So it's an opportunity to kind of clean up another part of the audio spectrum by using the sensor again. So the combination's very powerful because the main region where you see improvements in the sound quality by using a current output amplifier are mid-range and high frequency. And by contrast, the velocity sensor is really cleaning up distortion and controlling cone motion at low frequency. So yeah, you put the two together and we can then get some benefits across the whole spectrum, which is great, really nice.
We were kind of talking, and the VECO and the sensing is really focused on the low frequencies. And the reason why it's focused on the low frequencies and not the high frequencies is...
Well, this is maybe slightly philosophical. So, once you've got a motion sensor, you could try and use that to control as much bandwidth as you can, I guess. So, and certainly with an accelerometer, you could try and control the whole bandwidth. So everything, you're hearing is really controlled by that accelerometer signal. But I think, from my perspective, the mid and the high frequency output of a driver, you don't have a lot of cone motion going on there. So all the nonlinearities that are associated with the voice coil moving or the suspension stretching, they're not that relevant up there. And actually what you've got mechanically is quite well behaved. Things tend to, until they break up, which is a different story. But until then, they're just behaving more or less like, they're physically a mass. And they're quite predictable mechanically. And really, if you deliver a nice clean force signal on them, you will get good output, assuming you've got all the other wrinkles in your design right. So yeah, I think the way that we're approaching it is kind of a soft touch in a way. So from my view, having an amplifier which outputs a current, which has a high output impedance, that's enough to clean up the mid and the high frequencies. And the VECO is then focused on controlling the low frequencies. But yeah, it's been differently in the past, and other people may want to do it differently. That's how we're doing it.
I love it. And again, we're going to have some videos that kind of give visual representations, because this is kind of an interesting topic to wrap your head around. Now, when we're talking about all this, and you kind of already alluded to it, where this can really apply to hi-fi systems, but the first product that this is actually going to get released in, and we were kind of debating whether this fits into a hi-fi product, whether it's a lifestyle product, what it is. But tell me a little bit about this first product that it's going to get released in.
The first product is a brand new category for us. It's a soundbar with spatial audio called Zeo. And we're using VECO, the sensor, in the bass section of that. So there's 4 racetrack shaped drivers in that product, and that's where it's going. And that's kind of happenstance a little bit. It's the product where we were like, this would be really good in this product. Let's make a special push and get it in there. But the technology's, something that's really versatile. We can use it in a wide range of our active speakers. So yeah, there will be other products coming out too that maybe are more relevant to hi-fi listeners. But do pay attention to the soundbar because it's got this in and it's quite interesting. And yeah, I don't know, Jorden, we were saying, is this a hi-fi product? Is this not? I think there's some overlap on this, right? Because nobody lives in isolation, right? You tend to find people live with other people, and you don't always have a household where everyone's an audiophile. So, I think we've all had situations where we'd like speaker systems that we're not necessarily able to put in a room.
Yeah. That's fair. Not the most visually appealing for all members of the household, or whether or not the space actually allows for these larger systems.
Yeah.
And we were kind of talking about this, and yourself and a couple of the other engineers already have this soundbar in their homes.
Yeah.
And they have typically replaced like LS50 style systems or...
Yeah, I mean, that was me in particular. So I have had a prototype of the soundbar for a little while now. There's been a lot of work going on after hours, let's say. But in my kind of family living room, I had a stereo system with LS50s and a little amplifier with an optical in. So all our TV watching was going through this thing, and I'd listen to music on it. And yeah, so when I brought in the soundbar, I wasn't imagining I would ditch those. But it's funny though, because as well as, actually enjoying listening to the soundbar, even for, my music listening, I found I wasn't really missing the hi-fi. It definitely added a lot to my pleasure watching TV. But it also, I got rid of those speakers and we moved around the living room. Because it's like, okay, now I'm not constrained to have enough space either side of the TV for the speakers. So yeah, I mean, I don't know. Maybe I have to hand in my audiophile membership card now. But I can really see the appeal. And, I guess if we're trying to make a gallant story here, we say, okay, we're trying to democratize good audio.
Sure.
But from a simpler perspective, people want to buy products that fit into their lifestyle and their houses. And, I don't think there's any point in us fighting against that. And if we can offer them something which gives them more pleasure and a better experience, then we're going to do that. And that's case in point. And I'm hoping that people agree we've done a good job and they like it and buy it. That's the bottom line, right? Yeah. So we'll have to see.
Another kind of line that I want to just talk about, and you mentioned this a little bit, that this has been, you had the prototypes in your house for a long time, and this has been kind of going on for a long time. We're not talking a long time in terms of like months. We're talking a long time in terms of years.
Yeah, so that's right. I mean, it's been a slog, and there's a lot of overlap here. So I was trying to work on this thing while we were doing LS60, while we were doing KC62, and then before that, we were working, on the distortion controller technology that's used in LS60 and in KC62. And we're already saying, oh, wouldn't it be nice to have a sensor? Yeah. So yeah, it's been quite a long path to get here, and I think one of the things that is always the case with brand new technology is it does take a long time from the kind of initial, well, not even the initial idea, but just the kind of the motivation to start looking at a new area like a sensor and taking that all the way through to then having, maybe a few ideas that don't work and some ideas that you take a bit further, right to the point of having something in production. It's a long slog. And I was mentioning, Jorden, that we kind of just decided almost one day just to go, we're going to do this in the soundbar. And as a consequence, I guess, put a lot of pressure on ourselves. But sometimes I feel like with new technology, it's quite easy to bumble along with the research side on the lower priority, spending a couple of days a month on it. Whereas if you really want to get something into product, you kind of sometimes just have to say you're going to do it and tell everyone you're going to do it.
Put the date on the calendar. It's going to happen now.
Yeah. So I feel like it was a little bit like one of those situations. So we put ourselves under some pressure, but I think we got there. And it's, definitely taken us now to a point where we are kind of looking forwards at how we can use this in other areas in different products. So, the sleepless nights are behind me.
Until the next time. I think it really resonates with me, this idea that the audio, or maybe the soundbar that you're putting into it, is going to deliver audio that is not necessarily just for hi-fi people, or not necessarily just for the everyday person, but it's of higher quality than what you can do in a similar product without this technology. Yeah,
I think there are kind of emerging systems in the market. I'm not just from KEF, to be open and fair, where people are pushing the boundaries of what a loudspeaker can do in a particular size. And we've been doing that. We've been really trying to do that. And KC62, LS60, I keep mentioning those too, but they're really good examples. And if you're trying to do that, have a small package which can deliver decent bass, part of your recipe has to be a way to control distortion. And so there are people besides KEF looking at this problem. And VECO is like a really big step forwards for us. And I'm kind of excited that it's taking us a big step forward. So, but as I say, it's an emerging trend, and I think there'll be other people with similar tech and similar exciting stuff in the industry. So I'm looking forward to seeing some of those as well. And it's always great to see things springing up from other researchers, other manufacturers, and it gives us ideas, and ultimately ends up with innovations which reach products that the customer can buy. So it's kind of an exciting time, I think.
I love it. We're coming up to that 30-minute mark, roughly. So something that I didn't ask you yesterday, and shame on me for forgetting this, it's the kind of standard question at the end of every interview. What kind of music are you listening to right now? What's kind of motivating you when you listen to the music on, let's say, the soundbar, because that's the most relevant one right now?
Okay, the soundbar has been interesting for us because it'll be our first product where we've had like built-in multi-channel decoders, like Dolby Atmos decoder, DTS decoder. For us, that's a novelty. Yeah. So, I mean, I've obviously played around with a lot of other people's decoders and things, but doing it on ours, I've been watching more movies.
Oh, yeah?
And I'm not really a big movie guy, but because of that, I've been like kind of Friday nights, Saturday nights, right, what shall I watch on the TV and listen to some movies, which I've kind of really been enjoying. And not necessarily like high quality, highbrow stuff, just to kind of like, Star Wars, Disney's, things like, I've got young kids as well.
Oh, yeah. And they're at a prime age for some of the Star Wars stuff. Yeah. Do they like Star Wars?
Well, I got one that does and one that's a bit scared.
Oh, okay. Well, we're still, we're close on that age.
Yeah. So that's it. So that's taken up some of my time. But then in terms of music, which is what you actually asked, we got a guy here called Neil who's been at the company ages, and he does this really nice thing. I think the last time he did it was more than 6 years ago, where he collates a list of everyone in the department's favorite 10 albums.
Oh, no way.
And we just did it. He just did it like a month ago. And it's actually a really cool process to do. And the thing I find interesting is, I guess we're all of a similar mindset that we love music, right? So all of us in the department take this pretty seriously. So it's not like, oh yeah, I'm going to do this list in 20 minutes.
Yeah.
So I've been like then doing a bit of soul searching, like examining, what do I consider to be in my top 10? And I must say it's great. I would like advise you to do it. It's kind of a cathartic process, but it is also kind of painful because I found it's quite easy to get down to maybe 20, 25.
Yeah.
But the push for the last 10.
When you start cutting out the things and you're like, what do I value more? Yeah.
Exactly. And so we went through that. So I've been listening then to like a whole load of stuff in my collection that's kind of, I guess, a little bit like walking down memory lane, which is kind of nice because you start to think about like where you were when you bought albums or who you were with. Yeah. And actually what's quite nice as well is I've been here a long time, right? So a few of those albums as well, when I'm choosing them, I'm like, oh, I remember it was Mark who recommended I listen to this. He's still working here. And so that's cool. That's really nice.
Do you guys do group listening sessions with these albums?
Well, we haven't in the past, but this time another one of our guys, Alex, he made a playlist.
Okay.
I think he made it on Spotify and Tidal. And it's distributed it. And he's been really good at it. He was telling me he's like on the order of the playlist is in the order that people sent their like top 10 to Neil. So it's kind of random order.
Yeah.
So I know he was down like on the middle of Mark's, but I don't know if that's person 3 or 4. So
gotcha. I was going to ask actually, because that would be interesting. So you collect all these different playlists from all these different employees. You do a group listening session, and then you try and figure out who selected what.
We didn't do that, but that's a good suggestion. And I reckon we'd be pretty much on the ball with it.
You think so?
Yeah.
You're able to kind of pinpoint everyone's preference. I
think I probably could for like half of the people at least.
Gotcha.
I mean, the other thing people might not know about KEF is how many people have been here for a long time.
Yeah. So your tenure, the average tenure is quite long.
Yeah. So I might mention Mark already. He's over 25 years at KEF, and Phil is the same. And Neil's, I think, probably 15 years plus. I'm 20 years plus. Quite a few of us like in 10 years plus. So those guys, I kind of know. If I see a playlist, I'd be like, I reckon it.
Yeah, I've seen that.
I reckon it's George, I reckon it's Phil. So yeah, I think I could do that.
That would be so cool.
There was also some nice surprises. There's like some of the newer starters who've been here less time. I maybe don't know them so well. Looking at their top 10, I'm like, oh, you like kind of some similar stuff to me.
Yeah, I resonate with that. There you go.
Yeah. So that was very cool as well. So that's nice because we all get kind of very focused on the engineering side, and as a good reminder, like it's all about the music and the community as well. It's very cool once you do that and get people talking about what they like, and it's very nice.
I love it. Are you guys going to do like a listening party or something when VECO and the soundbar actually launches?
With the playlist of
that would be cool.
It would be, but that's like 200 plus hours of.
maybe not so much. Maybe that's a little too long for a party. But
I was thinking we should do something. I don't know what though, but it's been a lot of work for a lot of the team, and a lot of people have put in extra effort on it. So we'll do something. I don't know what, but we'll have to do something.
Absolutely. Well, it's really cool, and it's especially cool coming into like we've been here a couple times now. The last time I was here was almost 10 years ago, if not 10 years ago at this point. It's really cool because every time we come, there's a buzz about something. So last time, I think it was the Blade 2.
I think, if it was, this is your third trip, and I think, Jordan, you won the first.
Yes, I was on the first one, 2015, 2016, something.
Yeah, so we'd quite recently done Blade 2. We did a whole load of videos with you about some of our classic technology, like UniQ, which was nice. And I still like those videos are great if somebody's asking about UniQ. I'm like, well, watch this video.
Yeah. Oh, that's awesome.
And I mean, when you, I guess it's like looking outside and seeing if the grass is growing, right? If you're sitting in the house doing it all day, you don't really notice it. But we do have quite a lot of things that over time we try and improve and change. And maybe we don't see it as clearly as like you coming back 10 years later and going, oh, that's a new listening room. This laser thing's changed. So that's cool.
It's very cool. And I think what I gather from it is the excitement of all the people here. And hopefully our videos kind of convey that, but this VECO technology, everyone in the office seems to be very excited about where it is now and where it's going to go. And for those who get a chance to listen to the soundbar, and then, keep your eyes peeled for other products, because this is the first, but not the last. It's going to be quite a long run of this. So if you get a chance to listen to it, listen to the soundbar, wait for some more stuff to come out and get announced. Really exciting tech.
Fantastic. Thanks very much, Jorden.
Thank you so much for jumping on again, and all the best.
Thank you.